All right, so what we're going to be talking about today, like how do we go about drawing these things? How do we go about illustrating this? We're going to be using what are called Lewis structures. Lewis structures named after some dead chemist. It's one of the reasons to go into science, is to get stuff named after you, because that's pretty awesome. That you're just immortalized like that. Even though I don't know who Dr. Lewis is, but I know he's a dead scientist.
Like Einsteinium was named after Einstein.
Yeah, all those.
All the later ones are named after famous people.
Yeah, I know. It's someday. No, what am I kidding? There will never be a day where anything is named after me. All right. So anyway, what a Lewis structure is, in terms of this model. It's just a drawing that shows the valence electrons only. And that's one of the keys, is because only the valence electrons are the electrons that are involved in bonding. And so those are really the only ones that we care about. So to draw a Lewis structure for an element, step number one is you write the symbol. So you're looking on the periodic table to find the symbol of that element. And then you determine the number of valence electrons for that element, and we use a dot to represent that electron. Now you might be thinking, well, how in the deuce do we figure out how many valence electrons something has? Well, I'm glad you asked that question. You will want your periodic table. So I would encourage you to take those out right now. And I can come back to this. I know some of you are still writing. When we look at our periodic table, the way that we are going to determine the number of valence electrons is based on the group number. So the group number, this is group 1, this is group 2, tells us how many valence electrons there are. Now, depending upon what periodic table you're looking at, the top numbers have a variable numbering scheme. If you look at this one, it numbers it 1 through 18. If you look on the periodic table in the classroom, you'll see that they used Roman numerals, and there's this B group. That's another traditional way of numbering it. And then basically, we kind of just ignore the middle numbers. And this is, while it's group 13, we consider it group 3. While this is group 14, we consider this group 4, and likewise, and so on, all the way across. And that tells you the number of valence electrons. Yes, sir?
How do you find the valence electrons of like the middle ones?
It's a great question. We'll go over that later.
Okay, cool.
It'll namely be off of the charge. So again, one of the things that I might add, we'll go over this a little bit later, but I would also maybe put once we get into kind of how it works and what typically happens, you'll notice that the charges have a correlation with the number of valence electrons. So usually, with respect to this middle column, it's whatever the charge is going to tell you how many valence electrons. So if, let's say I give you iron, but I tell you it's a +2 charge, well then you know it's going to have 2 valence electrons. So that's kind of the easy way to do that. But anyway, so we just look at what group it's in. That tells us the number of valence electrons. And then the last thing is we place the dots around the symbol, putting 1, that's supposed to say 1, 1 on each side before you put 2. And that's how you draw a Lewis structure for a particular element. So let's look at some examples. It's all pretty simple. So let's look at oxygen. Get rid of my drawings here. So step number 1 is, what's the symbol for oxygen? Capital O. And then we look at what group oxygen is in. So you look on your periodic table, you find oxygen, and we find that oxygen is in group 6. And so that means it's going to have 6 electrons. What that means is that it's going to have 6 dots. Sorry if you guys can't read this. I need to change my background. So then the 6 dots we're going to place around the oxygen, putting 1 on each side. And what I mean by that, you can imagine that there's this kind of box around the oxygen. So I'm going to put a dot on top. I'm going to put a dot on the right. I'm going to put a dot on the bottom and 1 on the left. This is what I mean by a side. You put 1 on each side until, and then you can start doubling them up. So you kind of just go around and around in a circle. And that's a Lewis structure for an oxygen atom. So we're using the symbol. We're showing only the valence electrons. So I got one more example. So this is aluminum. So go ahead and try to do this one. I'll give you a little bit of a head start, and then I'll kind of talk through it. So we know this is an aluminum atom. So we look on the periodic table to find the symbol for aluminum. Aluminum is element number 13. So this is Al, capital A, lowercase l. Aluminum is in group 3. So that means it's going to have 3 dots. And then you just pick a side, and you just start placing 1 dot on each side. And so I get to my 3. Now it does not matter where you put your dots. If you decided, oh, I wanted to do mine like this, that's fine. Or this, that's fine too. What matters in your drawing is that you have the right number of dots. And again, you have not placed 2 on a side until every side has 1. Now, I've said that multiple times as a rule. And we are going to do a little simulation to kind of move forward. But unfortunately, in the simulation, I think there's some examples, simulations, where they don't follow that rule because they're not smart. That's just what I'm going to assume. So, but that's what we're going to do.